Hello, welcome to the hobby world of Dr. Mike. In this video we'll be talking about some repairs I need to make to the Williams master display. We'll also talk about repairs to the slave displays. Here's a drawing of the displays used on the World Cup pinball machine by Williams. And we had a number of problems going on with this machine and the displays. First problem is these last two digits on the master display board were fading out. These two digits were operating correct. Another problem was segment D on the master display and on player 1 and player 2 were out. They were not lit at all. Then we had another problem, this is a while ago, but we'll talk about it here, is that on one of the displays, all of the digits were fading out, but it only happened with one display. I moved the slave display card to another position, and the problem followed the slave display card. So we'll talk about these three problems. We'll first talk about the problem with segment D not lighting up. Well, through another drawing, I know segment D is pin 34 on the display glass. Segment D was not lighting up for the master display, nor was it lighting up for player 1 or player 2. Here's player 1, segment D. We can follow it back to this point, which also ties to segment D for player 2. And you can follow it back to pin 34 on the glass on the master display and resistor 4. So here's a common point where you have a problem with all of these displays. This would be the common point. So the easiest thing to look at is resistor 4. Here is resistor 4 on the master display card. And here is what the resistors look like on that display card. You can see these resistors have already been replaced. There's a little bit of burning on the board. These resistors do get hot. I checked the solder. We actually re-wet the solder on this resistor and it had no effect. But if you push the resistor with your finger, segment D would come in and then would go out again. We determined that the film in this resistor is probably broken. You can't see it, but the resistor is damaged. Here are the resistors on the master display card for my flash pinball machine. Pretty rough shape. Again, you can see many of them have already been replaced. So I decided to replace all of the resistors on both boards that I have. "10 kilo ohm half watt resistors are specified. I purchased 1 watt resistors. These are miniature metal film resistors in a porcelain case. And I mounted them a little bit off of the board to allow better airflow and cooling of the resistors. So hopefully we won't see these heating problems anymore. And all of the segments on all of the displays look good. We'll talk about the second problem experienced on the master display board. The plasma display, these last two digits would fade out and you couldn't read them. Of course, when you're playing a pinball game, this is where your ball number is displayed. So you'd like to have that running. I ended up replacing the display glass. But I did try a few things first, because these display glasses are fairly expensive. And you really hate to change them out if you don't need to. Strobe 7 and 8 actually drive these last two digits through an amplifier circuit. Now this IC chip actually has 8 amplifiers in it, and only 4 of them are used. So I tried transferring the circuits to some of the unused amplifiers, but that didn't work. The digits still didn't display properly. On the right is the digit display driver. This is where I transferred the circuit to unused amplifiers. And again, that did not work. This is the old glass that I removed. When I removed this glass, I did use the desolder station and remove the solder. Of course, sometimes the leads still stick a little bit to the board, but not really too bad. One of the things that happened though was these pins basically fell out of the glass. They're actually glued in on the lower piece of glass. I believe it's just pressure that holds these pins in for connection. But you can see on this glass that it appears to be some corrosion. You know, these interfaces don't look real clean. Whereas on the new glass, you can see they look nice and bright and clean. So I believe what happens if you lose a couple of digits is you're just basically losing the connection here. I've experienced this on my Black Knight machine also. And I really don't know of any way to fix this or correct it. My belief is the only thing you can do is replace the glass if you have a condition like this, or evaluate replacing your display system. And we'll talk about the last problem I experienced with these displays. It's kind of interesting. I don't remember exactly which display was bad. Let's just say for now is player 1. All the segments on the displays were fading out. Of course, a troubleshooting technique is to take the card, say on this player 1, that's bad, and move it to a different position. Let's just say player 3. And then take the player 3 card, which was operating correctly, and move it to the player 1 position. You see, did the problem follow the card, or did the problem stay in the position? In this case, the problem followed the card. That tells you that there's a problem probably with the card or the glass itself. The card itself is fairly simple. It's just a printed circuit board. You've got your connection to your jumpers and your connection to your display glass. So I started looking at the Keep Alive circuit. Now the Keep Alive circuit is there to keep the gas in your display glass ionized. It's supposed to help the segments on your displays to light up when they're needed to. Each one of these digits is strobed for a certain period of time. I didn't know how fast the strobe lasts, so I thought I'd hook my oscilloscope up to actually the master display card here. Actually it's wired up to strobe 7 and 8. And this is what I found. There's actually strobe 7 here, and this is strobe 8. The total time from the beginning of strobe 7 to the beginning of strobe 7 is 16.6 milliseconds. So each of these strobes is on for about 1 millisecond, which is quite a bit of time. There are various manufacturers that make these plasma displays, and they all kind of have different specifications. One specification said the reionization time is 7 microseconds. Of course, that's a very, very short time compared to when you're looking at milliseconds for each strobe. I also saw in the specifications where the on time for these displays can be 160 microseconds up to 200 microseconds, which again is a small percentage of the total time that each of these displays is strobed. So I thought, let's disable this keep alive circuit. Figuring, what am I going to do? Wreck the display? Well, the display was already wrecked. I clipped lead 35 on the display glass to see what would happen, in essence disabling the keep alive circuit. Here's a picture of the actual display card. Again, I clipped lead 35. After I did this, the display worked correct. All the digits were bright, all the segments were bright, had no problems. This was, again, quite a few years ago. I don't know how long this will last. You can see some, looks like corrosion on these terminals here. So this card may not last very long. Now this is against the original design. So if you choose to do this, do it at your own risk. This is something I did and it worked. This little orange dot is that keep alive circuit. It's actually glowing between the anode and cathode, and it's energized all the time. Just for fun, I thought I would disable this keep alive circuits on the slave display boards. It's easily done. You can unplug some jumpers that are actually buried behind the master display board. And here's a picture of the display board. It's actually displaying really well, and you cannot see the keep alive circuit anode and cathode glowing in there. So that's verification that the keep alive circuit was disabled. And again, you can see the displays are working properly.